Welcome. Welcome. So it's Wednesday. I'm Ned Pyle. That down there is Klaus. That over there is Phil. They'll be up here back and forth talking about some stuff. It's Wednesday noon, so by now I'm assuming your hangover is manageable. Okay, good. We're going to talk about software-defined storage today in a semi-professional manner. And every once in a while, I'll say things that are controversial or rude. And hopefully you don't take me too seriously. Like I don't wear the presenter shirt because I don't play golf. Okay, we have question breaks throughout, so we can kind of keep things under control. We have a lot of stuff to cover. You can feel free to shout them out when we get to these little breaks. Or you can go to the mic if you wish. And we'll repeat the question so everybody can hear. Okay, so Server 2016 came out on Monday morning. Hopefully by now everybody's downloaded their eval copies and started kicking the tires on their laptop. We believe that I believe we have made the biggest changes to Windows Server since Windows 2000. Since like Active Directory and Windows 2000 really came out and became a thing that everybody wanted to use, is to me what 2016 is now. The sheer volume of stuff. And here's the kind of slide you love to see, right, at Ignite. Oh, look how important I am. Look at all this stuff I did. There's so much stuff. Yeah. It's a good example of a slide that should get somebody fired. And they're usually like at least like a group manager or a VP when they have those. Okay, so maybe if we organize it, we've done all this stuff since 2012, since R2, all this stuff crammed into this stack, old and new, endless. That's still too much. Okay, so what we're going to do to make this easy is we're just going to focus this down to what is really truly new and innovative and interesting about storage in 2016. And if you haven't looked at 2012 R2 or 2012, we've got endless videos and endless Ignite sessions from before and stuff to fill in the cracks. So I'm going to start by giving this over to Klaus and let him talk about Storage Spaces Direct.
Thanks, Ned.
You're welcome.
So Ned and I work together, which means that's why I play golf. Chill. So Storage Spaces Direct. Let's start off with a demo. Right? So here we got this is Failover Cluster Manager. We got 4 servers in our clusters, which you can see from these 4 machines. It is all configured with a single storage pool, and we got 4 virtual disks that are actually doing work. One of them is just to collect some statistics. We've got a whole bunch of VMs. In this case, we've got 80 VMs, so you already calculated that's 20 VMs per node. And they're running something we call VM Fleet, which is an open source distributed toolkit where you can basically put your hyperconverged system under load. This particular system is a relatively pedestrian system configuration. It does 960,000 IOPS split between 90% read and 10% write. So that's just like, okay, we can do that with 4 servers in a very small configuration, SSDs and HDDs. Now, so what is this thing that we just showed? So Storage Spaces Direct is effectively using servers with internal drives, like inside the chassis, and you bring them together in a cluster, and then we can basically create a pool of that storage across the cluster. That means it becomes highly available and scalable, because we can simply just add nodes and expand the cluster to provide either more capacity or more performance to the VMs that are running on the system. A shared nothing architecture, which is what Storage Spaces Direct is built on, will then be able to use devices that are not inherently shareable. And what I mean by that, if you think about an NVMe device is effectively a piece of SSD that sits directly on a PCIe bus in your server. You can see how 2 servers cannot physically connect to it because it sits on the PCIe bus. The good thing about NVMe devices is they are extremely good performance. right? later this afternoon, we're going to talk about how you can actually get hundreds of thousands of IOPS out of just a single device, compared to a typical SATA SSD that typically tops out just shy of 100,000 IOPS. Now, the SATA devices also have their role. So SATA devices are also not inherently shareable, but they come with a very low price tag, which means that compared to what we did in Windows Server 2012, where we always require you to use SAS devices, you can now use SATA devices, which are it's certainly on flash systems relatively cheaper. And then finally, we will not have a storage fabric. We actually use traditional Ethernet or RDMA-enabled networks to create a storage fabric between the servers. And that is where all the east-west traffic or the intra-node communication is going to happen over the regular Ethernet interface. So no need to worry about SAS cable configuration, the sharing capability of it, the distance limitation that SAS has, which is 5 meters, which I suppose is like 16 feet for Americans, yes. And then it's available in Windows Server 2016 Data Center Edition. So what storage can we actually use? What storage configurations can we have here? So the first thing is very common. We're going to have 2-tier physical storage configurations, right? So SSD plus hard drives. That's probably going to be initially the most common one, which is a hybrid configuration. You got some flash, some traditional hard drives. The second one is you move to an all-flash, where you will use some NVMe SSDs combined with some SATA SSDs. The top devices are we use for cache. Now, there is a third configuration that is not that common out there for people who provide this type of storage, which is three tiers of physical storage. So in a 3-tier configuration, you actually have a system that has NVMe SSDs plus SATA SSDs plus HDDs. So we can actually use the NVMe devices for caching, accelerating both read and write I/O, and then we can tier in the secondary storage between SSDs and HDDs. So you can place the coldest data on the HDDs and the slightly more hot data on the SSDs, with the super hot data being in the NVMe devices. On the networking side, I already gave that away. We can use Ethernet network. It needs to be 10 gigabit or higher because there is a fair amount of traffic that will happen on this network as users are requesting data and or the system is doing internal operations like rebalancing storage when you expand the system, or is doing servicing. For RDMA, to make it a lot faster, RDMA is a networking technology that significantly lowers the I/O latency, sending data across the wire, and it also reduces the amount of CPU assist that the networking transport needs. So it gives CPU back that we can then use to actually run our virtual machines. Now, so how does it come to market? So we have a program that we call the Windows Server Software Defined. And in this program, our partners are building hardware configurations that adhere to a certain set of requirements and put them through a rigorous validation and stress testing to make sure that they work well with our software-defined technologies. This actually goes across both networking, storage, and compute. So we have 12 hardware partners that are showing off hardware configurations that are in this program, and they have at least one configuration each. A lot of them actually have multiple configurations they are bringing to market, either bringing like hybrid and all flash or various other variants of the configuration. So go, if you want to see them, most of them are represented here at the expo floor. You can go see them. So in terms of feature capabilities outside of the base being able to use servers with internal storage, we do have a built-in always cache. What does that mean? That means that every time somebody writes data in a VM, it gets absorbed by the cache drives. The cache drives is basically automatic setup, and we are automatically using the fastest devices in the system. Then, as needed, the data gets moved from the cache drives out into the capacity drives. As data is read, it gets cached in the cache so that subsequent reads of the same data comes out of the flash cache instead of the rotational media. What does that give you? That gives you a lot better performance that you would normally see on a system like this. So one anecdote was we had a guy in Microsoft who was setting up the system. He's not affiliated with the product group where I'm from, where we developed this. He basically said, I am seeing my hard drives are reporting that they run 600 IOPS per second. That's not possible, right? A hard drive, a SATA 7200 laptop drive can run like, what, 100 IOPS maybe at best? I said, well, what you're seeing is essentially the effect of the cache drive. Because we can drive the hard drives more sequentially, you effectively, even if you run a complete random workload, which all VMs are, we can drive these devices much more efficiently and therefore gives much more performance to the end users, which means you can get away with buying cheaper stuff, which I assume you want. The second point is that we create and take all the storage into a single storage pool, right? So once we have the storage pool, we can then, from the storage pool, we can then create the volumes where we store our data on with the various resiliency types that we want, whether we want mirror, whether we want parity, et cetera, whatever fits the workload. The scale starts, as was announced yesterday, with 2 nodes. If you have been following me or somebody else talking about Storage Spaces Direct, you've probably seen, hey, we started by saying you need at least 4 nodes. And then about 4 months ago, we said, well, actually, you can also use 3 nodes. And then this week, we're telling everybody that you actually use 2 nodes as long as you use a witness service, which is either the file share witness or a cloud witness out of Azure. We can scale up to 16 nodes with this first generation here. Typically, you'll find them in like 4, 8, 12, 16 node configurations, which can get up to delivering massive amount of IOPS, which I demonstrated on Monday by showing a system running 2.7 million read-write MIGs, or up to 6 million and more using just straight-up read from a system like this, all flash. In these systems, you can put more than 400 drives, and there are supposed to be 400 squares across these boxes. You're not going to get the time to count them all because I'm going to move on. So the other key innovation that we have doing is like, if you're familiar with parity and how parity works, you know that parity is great if I want to write a bunch of data sequentially, like backup, and then at some point in the future I want to read it. But if you do high change in the system, then parity has a problem because you have to go through what's called read, modify, write. Which basically means I cause a lot of additional read. I have to modify the data with the stuff that I needed to update. Then I have to recalculate the parity. Then I have to go write that out on the entire system again. So the way we deal with that is we introduce something called accelerated erasure coding. Erasure coding is a different way of talking about parity. The erasure coding algorithm that we use is the local reconstruction codes. That is the exact same algorithm that is being used in Azure today. So how we make this go faster is that we basically front a parity volume with some piece of mirror. So all the writes that goes into this volume land on the mirror initially. And mirror is super fast in writing. And then, as needed, we move the data from the mirror out into the erasure coded portion where it's super capacity efficient. And if you read that data again, that's fine, because read has no overhead with parity. And if you later on need to update the data and write the data, we actually write the new data into the mirror, and then the process starts over again. We will talk a lot more about how this works in the 4 p.m. session. So what configurations, what deployments do we support? So here's how the system is. You can run it as an SMB3 file share, basically what we introduced in 2012 as the scale-out file server. There's one deployment. You can then store SQL Server databases on it, or you can support VMs on it, et cetera. You can also run it hyperconverged, where you have VMs running straight on top of the same cluster where our storage is sitting inside. All right, so we run compute, networking, and storage all in the same set of servers. Or as we announced yesterday, you can run SQL Server straight on the cluster with Storage Spaces Direct, bare metal. So these are the 3 most common deployment scenarios. So I want to invite up Phil, who's from Accutech, and he's actually been using some of this stuff for a while.
Thank you, Klaus. OK. I'm going to talk about maximizing disk utilization with Storage Spaces Direct, what is commonly known as the capacity parity 3-way mirror question. Now, let's do a bit of history here, though. I, as many people in the room know, have been using scale-out file server and storage spaces since it was first released in Server 2012. About 2.5 years ago, what we now know as S2D was in its absolute infancy. It was actually at M0. and very flaky and leaky code. And Klaus said to me, no, Phil, this is very early, it's very dangerous, it's not very stable at all. At which point I completely and utterly ignored him, right? And then I went out and I put this very early M0 code into production and have had it in production ever since then. So let's think about that. I've had Storage Spaces Direct in production now since early 2014. It has run perfectly, and I have never lost a single block of data once. That is testament to the quality of this product. However, let's talk about some of the downsides of Storage Spaces Direct, because I'm not Microsoft, so I can be honest. Shared SAS was quite good because we could do things like two-way mirror, right, which was 50% disk efficiency. Unfortunately, with a non-shared system, like Storage Spaces Direct, raw disk efficiency is absolutely appalling. By default, you've got to use a dual parity mechanism. Why have you got to do that? Well, think about it. Every time you have to patch a node, every time you have to take something offline, you're losing the data on that node, which means you are running a degraded volume. So if you don't have at least 2 other copies, if you have a disk go bad, bye-bye data. Not a good situation. Now, the upshot of that, though, is you have to use either three-way mirror or parity. But three-way mirror only gives me 33% disk efficiency. So I've saved all this money with this fantastic new Storage Spaces Direct system. I've used these cheaper SATA drives. I've got this great performance from NVMe. But I've only got 33% of my disk. This is not a good situation. So you say, I know, I'm going to use parity. But parity doesn't have very good I/O performance when you start doing random I/O because of the computation you have to do. I now have a problem. I either have to buy bigger systems and spend money, or I get bad performance. I'm a service provider. This is a problem. So, fortunately, Microsoft came up with a solution, mainly because I yelled at them. Sorry, forgive me. Mainly because I yelled at them for about 2 years saying, I need better performance. Now, they have file system level dynamic modification of data layout, RFS dynamic tiering. This is very, very, very important because it allows inside the file system using RFS to dynamically move the data from three-way layout to parity layout. So I get the best of both worlds. I get performance and read-write performance of a three-way mirror, but I get the capacity capabilities of parity. Here's the nice thing about this capability. It can be changed dynamically, but when I set up the volume, and I can change the amount of the volume that's blocked out as three-way mirror and this parity. Microsoft thinks of this as being the performance tier and the capacity tier. This is dynamic and completely transparent. Why is my clicker not working? There we are. Right, fine. So this is dynamic and completely transparent to you in operation. And the thing is, I therefore get the best of both worlds. I get the storage efficiency of parity and the read and write performance of three-way mirror. Now, as I've just said, this operation is completely transparent in operation and is accelerated using the cache that Klaus has already summarized. So let's think about this for a second. I'm getting dynamic layout to data modification, and I'm getting the performance enhancements of an SSD or NVMe-based cache to give me that fantastic I/O. And I'm therefore achieving 64% plus raw disk efficiency. So even though I'm now in a shared nothing scenario, I'm getting better disk efficiency than I used to in shared SAS under two-way mirror. That was only 50%. And I'm now getting 64% plus. Plus, almost all of my I/O is accelerated. Now, let's think about this in more details, and I'm clearly walking far too far away. The goal here is that I am driving down my costs to serve. Remember, I am a service provider. I want to drive down my cost per gigabyte. But at the same time, I am driving up my performance to very high levels. If people have seen some of my other sessions this week, I have shown systems running in the millions of IOPS, and Klaus has also shown some systems. And at the same time, I'm achieving all of that with commodity hardware driven and enabled by the power of Server 2016. Klaus, I will let you pick up again.
So I already plugged my own session, but later today, we're going to talk about Storage Spaces Direct in more detailed, so at 4 p.m. So this is time if you want to go there, bring out your camera and take a picture of this so you know where to go. Here's the site, the main site for Storage Spaces Direct. There's a blog that I frequently try to update. And also, if you have feedback and don't know my personal email, you can always get to me and my team, actually, using the s2d_feedback@microsoft.com. That will go straight to the product development group. There's no filter involved. And then the different way to put feedback in is to use the Windows Server user voice. And then finally, Cosmos, who is one of my colleagues, and I are active, or try to be active on Twitter, and telling the world when we do stuff and when our partners do stuff. So, any questions on the stuff we've covered so far? We'll take a couple of questions if you got them. That's fine. We are here after the show, after the session, and can take some questions. Let's switch gears a little bit. Let's talk about storage quads. So storage quads is the other angle you will want to use on your storage because it effectively controls the I/O any given VM can do. You can set a minimum, a reservation. You can set a maximum to make sure they don't consume and throttle over each other. That's the basics of it. So let's do a demo. So remember the demo I did before with the system that ran 960,000 IOPS? So what I'm going to do is going to take my 80 VMs and just going to slam a storage policy on top of them. Right? Because I don't want to give my first 80 VMs all the perf. And then later on, when I have to load up more VMs, I really don't have any IOPS to give from. So the policy that we put on is basically getting to 5,000 IOPS per VM times 80, which throttles the system back to doing exactly 400,000 IOPS. That's how quickly that went. And the reason this is important is because when you build a system like this, you put the first couple of VMs on. I mean, if you don't control them, they're just going to consume everything they can. And then as you load up more VMs on the system, they're going to now start competing with the other guy. And the first customer that was put on the system is going to say, hey, now it's not running as fast as it was the first 2 weeks. Now it's running even slower. So you set the expectation up front. You sell them an amount of IOPS, or the business unit, if it's not a service provider relationship, say, this is how many IOPS you get. Right? And then you use a control with storage quads. So storage quads is an ability to mitigate the noisy neighbor, the guy who wants to just consume the world. It monitors the virtual machine storage performance continuously and manages the storage I/O. Right? You can do IOPS, you can do bandwidth, and it uses something called a normalized I/O. What does that mean? That means that basically I/Os are treated as 8K I/Os. So if you send a 4K I/O, we treat it as an 8K I/O. If you send 16K I/O, we treat it as two 8K I/Os. So if we give you 5,000 IOPS, you effectively get what is like 5,000 8K IOPS. What the I/O size of the application doesn't matter. It comes back to this normalized IOPS. That's how you manage it. Now, the policies you can set is effectively you can set a minimum, which means that this VM will receive no less than a given amount of IOPS. You will get alerts if the VMs are not meeting or getting their IOPS that they requested. You can also set a maximum, which means no more than a given set of IOPS. That's probably the most common one. Right? It applies to a VHD. Because it applies to a VHD, you could theoretically set a different IOPS per VHD inside the same VM if you really want to micromanage this. Most people, I suspect, will not. You can do two set of policy types. You can do one which is dedicated, meaning that each VHD gets this amount of IOPS. That's the one I showed. Or you can set the one that is an aggregated policy. An aggregated policy is effectively a way to say this collection of VMs and their VHD on aggregate gets this much throughput or IOPS. Right? So say a customer has 20 VMs on the system. You say, well, I don't really care which VM consumes how much, but you paid for a total of 20,000, so I'm going to give across your VMs, I'm going to give you exactly 20,000. You can decide what VM uses what. That's how you would use an aggregate policy. All right. Ned, you want to talk about storage resiliency from the VM point of view?
Oh, I suppose. VM storage resiliency is something new to 2016 as well. Has anybody heard of it? We've done a terrible job of advertising it. All right, you guys did good hunting. The idea is that, and if you go watch Eldon talk about this at his all cluster session, which happened yesterday, or go watch the recording, he likes to go into details of his experience. The experience was storage can have transient failures just for a short period of time. And as we add more and more software-defined storage, which relies on software-defined networking, which relies on other stuff, there's a lot more software happening and a lot more interesting new fabrics happening. The idea that you can have transient problems that by the time you even notice them, they're already gone becomes much more likely. So the idea about storage resiliency is to say, instead of just the instant I can't talk to the storage as a VM, I should just crash, which has always been the way of a Windows machine. Maybe I should wait. Like, just give it a second or two. See what happens. And as soon as I get notified of this problem, I will just pause myself, and I'll pause all my I/O, and I'll pause all my operations. And if the problem gets fixed within a set amount of time that you can control, I'll just resume. And this all sounds like a very obvious thing because it is a very obvious thing. After the storage recovers, we just come back online. It's all been alerted. It's all been annotated. So even if it's 3 in the morning and nobody was awake to notice this, you'll know that you've had problems. But theoretically, your users and your apps, their only experience will be like, it's weird. It kind of stopped. It's working. I don't know. Computers. Okay? Related to this is a new VM startup policy. So we got VMs so they'll keep running all the time. That's good. But what about when I'm starting them up from the beginning? Who runs domain controllers in VMs? And then SQL servers in VMs, file servers in VMs. Which one do I want to start first? I want the SQL server going, but he probably needs the domain controller. And I definitely want the domain controller going before anybody tries to access the file servers. So how about if we chain this all together and say, instead of just setting a priority, which you would do in 2012, I would say, okay, all the DCs have to start, or at least some of these DCs have to start. And once they're started, and they've told the cluster, like, yeah, I'm running, then we can start up SQL servers. Then we can start up file servers, and we can start up whatever application servers you need. Again, this sounds like a really good idea because it's a good idea. Okay. Now, you heard REFS from Phil the Lunatic Moss. I like how he does his presentation. He basically makes it sound like me and Klaus are morons. And then like at the last minute, he's like, oh, okay, you're all right. You're not morons. 5 minutes of moron, 1 minute if you're okay. Thanks, Phil. 4 years straight like that. Okay. REFS, we refer to it as REFS v2. The actual, confusingly, the actual internal version number is v3. Sorry. This is sort of like, think of it like Windows 6.2 kernel versus being actually Windows 8.1 brand, okay? REFS is the secret sauce that makes S2D work well, that makes your hypervisor work well, that makes your hyperconverged infrastructure work well. We spent a lot of energy on it in this release. I mean, you remember it came out in Windows 8, right? You remember that? And then you forgot about it because we forgot about it? Okay. So, I'll just do a demo. Let me just show, I'll prove to you right now that you're going to love REFS. And anybody who says, I don't love it now after seeing this demo, well, you're an idiot. But I'll do something for you. Come talk to me after. Okay. This is my server. And you can see I just had one big drive there, and I'm formatting it right now, okay? I'm formatting N for NTFS, so that I don't forget. And then I'm formatting the next one. Any guesses on the drive letter? R, good, for REFS. Now remember, same drive, same disks, same storage, just different volumes. That's the only difference. Now, in Hyper-V, I'm going to create a new VHD file, a VHDX file, really, fixed size. Okay, I'm putting it on the NTFS drive. Right here, N, note, nothing up my sleeve, 200 gig. Any guesses? How long this will take? Let's watch. Here we go. Most exciting demo ever. I don't know what would happen to the survey if I actually let that run for 6 minutes. Okay? It's done. 6 minutes. It's writing zeros. The entire file VDL extension happened. This is NTFS. It was written in the 90s. In the world of that, 200 gig would be 10 times the drive you could have had there. There's the file. It really got created. It's done. Okay. Let's do REFS. Any guesses this time? Okay. I heard 3 seconds. Here we go. REFS, R drive, 200 gig. Finish. Sorry, it wasn't 3 seconds, it was no seconds. You're so overestimating. Done. And that's not like I pre-allocated some stuff, I'll do some background work, and eventually it'll be a 200 gig file. We just altered the metadata on the file system and said, here's the beginning, here's the end, here's your file, goodbye. So, as close to 0 as we can make it. It's not actually 0 because Einstein. Okay. REFS, very efficient checkpoints and backups, very efficient file creation, as you just saw. Extension, it's massively accelerated. I mean, I don't know what the order of magnitude difference is between, 500 milliseconds and 6 minutes, but it's a pretty good ratio. All that I/O I saved, that 6 minutes was like my server thinking about making a VM and thinking about very little else. That's all erased. So what you can honestly take away from this is I have now removed multiple coffee breaks from your day. So technically this is a very bad feature, I'm sorry. And then at the end, REFS brings along a lot of interesting pieces. Besides the pieces that Phil and Klaus talked about, it has enormous data integrity and repair options. It scales much larger. It's just all around the future when it comes to things like Hyper-V and SQL and big app data workloads. Okay, so you saw the thing where I created the VHD, and nobody argued with me that it was good. Let's do this. VM checkpoint. I'm creating checkpoints on these machines, and I ran them and ran them and ran them and ran them until I had a bunch of I/O caught in my checkpoint. And checkpoints are used in multiple ways. You can restore them to do stuff, or you can throw them away, or you can use them to make backups and things. And the backup system of Hyper-V actually uses a checkpointing mechanism. You can see here it's about 74 gigabytes of stuff in my REFS one. It was about 72 in my NTFS. So now, let's delete this checkpoint on NTFS and merge the changes. Here we go. 7, 12, looking pretty good. 51. 52. 53. It's a Microsoft progress bar. Okay. It's an extra Microsoft progress bar because it went from 0 to 50, from 50 to 91, and then it'll go to 100 because Microsoft. We have literally made an entire new erasure encoding system of storage, and we still can't get progress bars right. Okay, let's try REFS. So that was 4 minutes. Not awesome. Especially when I'm trying to restore something or merge something to get back into operation. So here's REFS. Same storage, different volume. That's the only difference. Delete my checkpoint. Microsoft progress bar. 60, 70, 75, 80, 90, done. What was that, 4 seconds? Pretty good. And it's really there. The merges really happen. Nothing in the background. Thanks, and I'm going to give this back to Mr. Klaus again.
Thanks, Ned. So we loving the REFS already? I would. And by the way, we will probably end up calling it REFS v3. I just want to make Didier happy. Oh, you too. All right, I got 2 customers that are happy. Let's talk about the health service. So health service is brand spanking new in Windows Server 2016. Its purpose in life is to make sure that we have a singular way of actually expressing the health of a storage system like we have just shown here. So there's no slides. It's all going to be one demo. So in this case, we're taking a system that has a bunch of storage nodes. In this case, we got 3. And we're looking at what kind of status do we have, right? So the debug storage system, with some very cool named commandlet, will actually show you that there are no issues, right? Now you get to be IT pros that are debugging stuff, just like devs are. So in order to do something, make a fault happen, we just pull out a disk like this, right? All right, the disk disappeared. So let's see what the health service is actually thinking about that. So we run the command again. And guess what? Hey, there is a severity of minor because there are other servers in the system that has the data already. So there's no data accessibility loss. There's no data actual loss. But we says that we've lost the connectivity to a physical disk and check that it's working properly. It's sitting in slot 10, and there's a whole bunch of information. This is actually an older screenshot. There's a whole bunch of information that tells you slot 10, this server, and potentially if you annotate the system in this rack, in this data center, et cetera, et cetera, et cetera. You can put all that information in there. Now let's do something else. Let's say, well, we had a flaky network. The network cable fell out of the server, right? Or somebody took it out because they had too much fun at some party. So let's run the command again. So now we have the disk failed. We already know that one. And now we say the network interface, in this case a Mellanox, has become disconnected. How about go reconnecting your cable? Because that'll probably fix it. So we go do that. We put the cable back in. We put the disk back in, this ginormous disk. And then we ask the system, so how are you doing? Guess what? What is it going to say to you? I am doing great, thank you. Well, it's actually not saying anything. It's just saying, there's no more issues. So not only did we surface the issues, we also just took them away without you having to actually acknowledge and moving from a queue, et cetera. So it's just a dynamic state of what the system is doing right now. So let's do something that is maybe more entertaining. This also happens. All right, so what in this case? What does get reported here? So immediately the cluster node, we see the cluster reports that the server is down. We get a bunch of physical disks that we effectively have lost communication. Yeah, because the server went down. They're no longer reachable. So the cool thing is if we actually go and ask the system, we don't get a spew of 21 error messages, 20 for the disk and 1 for the server. It just tells you, hey, why don't you go and just get your server working? Because we know that if you get the server working, it's most likely that the disk will also work. All right, so you basically aggregate these faults and only present the one that is meaningful to actually address at this point in time, which is put the damn cable back in. All right? And as you put the cable back in, the server comes back, it presents itself as being operational, the system automatically fixes itself, et cetera, et cetera, et cetera. It's all happy and everything is hunky-dory. So this is the health service providing health status into upper-level management tools. You can use it straight as it is, as PowerShell here if you want to. There is a System Center Operation Management Pack that actually consumes this straight up and reports it into System Center. Or you can write your own, or third parties can write their own building on this infrastructure and making it a lot simpler. So instead of the outside world having to understand how all the intricacies of storage is, we have a health service that reports to the outside world what the health of storage is. Makes life a lot easier. The other half of Storage Spaces Direct, the health service in Storage Spaces Direct, is metrics. How many times have you asked yourself the question that says, how is my performance? How much CPU am I using? How much memory am I using? Well, in a single machine, you fire up Performance Monitor, you look at a whole bunch of metrics. What if you have a cluster? Now you fire up a whole bunch of performance monitors, you look at a lot of data, you type it in Excel, and you get Excel to do add for you, and you get all your information. But hey, wait a minute, we can probably do better than this. I thought I clicked. Let's try again. All right. So simply, just on the storage subsystem, we asked get the storage health report, which actually reports statistics, not health, because we're so good at naming these things. So the system you saw before, running 80,000 IOPS, because we put storage costs on it, says, hey, I'm running 80,000 IOPS. The storage metrics reported that. There's other metrics we can put in there, like how much throughput are we doing? Like in this case, 312 megabytes. How much capacity do we have? How much is available? How much is the CPU across the cluster? That's the average CPU across all the 4 servers. How much memory do we have? A terabyte of memory across. What's the average I/O latency? So see here, we're actually doing 270 mics on this particular system, which is pretty good latency for a system like this. So this makes it super simple to understand the performance metrics around a system like this where you don't have to necessarily invoke n number of perfmons and Excel to add the data up. And again, we have partners who have built solutions, visual solutions on top of this, so you can actually see it in more fancy speedometers and bars and stuff like that. So, for all of us, are there any questions so far? It's another question break. Or were we so awesome in presenting this that there are absolutely zero questions? All right, Philip.
So, pulled the drive, you popped it back in, you do the health check. Where does it tell us that the drive's being resynced or the server's being resynced?
All right. So the question is, how do I know that when I pop the drive back in that it'll be resynced? There are two ways you can tell that. One is we will have a storage job running that is doing the resynchronization. So if you do get-storage job, it'll tell you that the job is running and how much it progressed. Give you some idea when it's going to finish. You can also go, which is a more crude way, you can go and look at the status of the virtual disk using get virtual disks, and it'll say whether it is healthy or if it's repairing or some other state that might not be healthy. So why is it not exposed inside the health service? Because technically there's nothing wrong with the system at this point in time. Yes? So if you're doing the checkpoint merge under CSV, what kind of speed can we expect? Pretty much the same speed you just saw in the demo. Because what really happens under the covers, so it'll give me an opportunity to actually explain this. So in an NTFS file system, we actually, where you have the original data and then you have the data that was written to the disk after you created the checkpoint. What happens in NTFS, when you merge, you have to go read all that change data and write it back into the original file, which is a lot of storage I/O and takes time. With REFS, what we effectively do, we're using pointer arithmetic, metadata updates, if you will, to just define all the new storage in the right places in the old file. So the amount of data that actually goes to the disk is very, very small. So not only does it actually, so this is the second point of it, it occurs really fast, which you saw in the demo. But the other part is that the overhead on I/O on the storage subsystem is a lot smaller. And guess what we can do with those I/Os? We can sell them to other customers.
During the previews, we noticed a big difference between when the VM is running on the older node of the CSV or not. That was about a factor 9, which still isn't bad, but it's a huge difference.
All right, so he noted in the preview that it was a factor of 9, so it went from 2 seconds to 18 seconds.
If it's not on the older node of the CSV.
All right.
That's the expected.
That I don't have data on whether that changed much, so I can tell you in about a week when I've tried it. Other question?
So, small side dual node scenario. I shut down one node for maintenance, hard drive goes bad according to field data loss. Yes or no?
But, so, when you shut down a system like this, there is no data loss. What happens is a server is offline for maintenance operations or because it failed. The server itself, like a motherboard failure or something like that. Hang on. So in that case, the data is unavailable. Of course, in a two-node configuration, you only got one copy of your data left. So if something happens on a device over on the other node, yes, then we take the storage offline because there's no path to continue. So you can tolerate, in a two-node configuration, you can tolerate one failure. Whether that failure is a server failure or a disk failure, it's the same result.
But when I bring the node back from maintenance, my data is back, right?
Because the system will effectively go offline immediately, then the data will be, assuming no other failures happen in the server you took offline, the moment it comes back, you can actually repair your data. All right. Oh, we got one more. One more.
Just real quick, on this, when you run the health check, when you run the PowerShell, you just pull the hard drive out of the shell, there's an error, put it back in, it's not there. Is that data captured somewhere to kind of audit? Do I go back and see what happened?
So is there an audit trail for what happened here? That is probably one of the areas where we need some improvement on. But System Center would probably track it, yeah. but the service itself. Yeah. We will have another break if you don't mind, so just so we keep things moving. And we will be available after here up front to take questions if we did not get to it during the session. So with that, I want to hand it back to Ned on his very own feature.
Got my very own feature. Unlike inheriting SMB and DFSR, is that what you're saying? Nobody wants to admit they inherited. Well, technically, I own FRS. Any big FRS fans out there for Sysvol? Yeah. No. You don't count, Slav, because you're a crazy person. Okay, Storage Replica. You've all by now hopefully heard of Storage Replica. Brand new 2016 feature, not an evolution of DFSR or something else, brand new. Why did I make Storage Replica? Why did we work on this? It's for disasters. What are disasters? I mean, in America, these are disasters. Hollywood disasters. I'm not commenting on Michael Bay's directing as being a disaster, or maybe I am. This is definitely, by the way, not King Kong. Absolutely not the registered trademark of Universal Pictures, King Kong. A real disaster. Anybody remember 4 years ago, come next week, what started happening in Manhattan, New Jersey, up the eastern seaboard? Hurricane Sandy. Here's what it looks like when you drive into the Battery Tunnel on a normal day in New York. And here's what it looked like after Sandy. The top there, you can see on that pole in the middle, the top of that is a dump truck that some city employee abandoned and swam out on, I guess. Take the subway? Nope, not today. So all those employees not at work, all that data going over network connections that are typically underground. How big's that storm? Well, there's New York, there's Chicago. That's a pretty good long distance. I will help all the Europeans here. I knew you were going to call me that 5-meter thing, Klaus. I'm ready for you. And Phil can't complain because he's British and he taught us all this nonsense. Okay, we'll get a little bit more serious. Storage Replica is storage agnostic. I don't care what kind of data drives you use. I don't care if they're storage spaces direct or locally attached or SATA or SCSI or iSCSI targets or anything. I don't care. I don't actually know. I have block level, not file level, block level replication. I use, just like storage spaces direct, SMB3 as my fabric, as my transport. And with synchronous replication, I give you 0 RPO. No data loss, 0 data loss. You can also do asynchronous, but I gave you for the first time in Windows Server the ability to not lose a single byte of data. Thank you. We got there. It only took 20 years. We got there. Okay. Synchronous or asynchronous, and that means between floors, buildings, campuses, cities, countries, continents, whatever you want. Because I do synchronous and asynchronous, it doesn't matter, right? Synchronous for short, asynchronous for long. And I can do 3 main scenarios. I can create, all new, a stretched cluster. That's a single cluster where I just put a bunch of nodes in one side and a bunch of nodes on the other side. As few as 2, as many as, I don't know, what's the maximum you can do in a cluster? It was a 64? Whatever, who the hell does that? All right. Automatic failover then. So I got a stretched cluster, I manage it just like a regular cluster. There's nothing special to do. It operates like a normal cluster. It's cluster aware. We added site awareness in 2016, finally to the cluster service. So it can say like, this is New York and this is New Jersey and these VMs tend to be in New York and unless all of New York goes away, don't go to New Jersey. Don't go to New Jersey anyway. It's a terrible place. Anybody here from New Jersey? I'm sorry. Okay. It's asymmetric storage. So this is like the classic shared storage that you've been using for the last 16 years. We are going to eventually support a stretched S to D, but just not quite at the RTM day that we got right now. We need a little bit of time to finish that part off. but I got a solution for you if you're worried about that. Just keep listening. You manage it with the Failover Cluster Manager. We even extended that UI. It's got new wizards. The entire experience can be just like you were used to. Or you can use PowerShell. Then we also do cluster to cluster. So for the people who said like, oh no, I can't do Storage Spaces Direct stretch clusters, hey, it's okay. You can do cluster to cluster. They can both be S to D or whatever. And I do, at this point, do manual failover or orchestrated failover, right? I could use Azure Site Recovery at some point here shortly after we GA. I could use PowerShell. I could use VMM. All these things work. They've all been plumbed through for this. And I can use that S to D that makes Klaus happy. Good Klaus. Okay. And then finally, for normal people, I can use server to server. Because we'd like to talk about clusters like the only thing anybody has is clusters. Because we're on the cluster team. Well, I realize that most servers are not clustered. What's cool about this is 2 separate servers replicating whatever I need for some weirdo workload that maybe isn't like, the data's important, but the availability isn't that important. Some financial reports that we only update once in a while, but I definitely want to be able to read them when I need to read them. Manual failover, but the nice thing about this and all of these is it runs in the guest, runs on a host. You want to do VMs, that's fine. You want to run replication between some VMs on VMware and Hyper-V, yeah, I don't care. Between on-prem and into Azure, don't care. Between AWS and Azure, yeah, sure, don't care. You manage with PowerShell, or you come to my session tomorrow at 4. This is called the bait and switch. That's what this is technically called in the United States. And you'll be there and you'll see my secret. And you can even do server to self, which sounds really stupid. But it's not. Because I ran into a bunch of customers who said, hey, I bought all these expensive SANs, and then I bought some more expensive SANs later, and they can't replicate. And I want to be able to migrate data from one to the other. What if I just replicate, like if I just point a LUN here and point a LUN there and let Windows take care of it, and then I can go back to using my new SAN, whatever. Sounds pretty cool. You can do that. The requirements are pretty easy. You need data center. We'll run in all versions of data center, including Nano. You need, for now, hint, Kerberos. So it needs Active Directory now, maybe not later. You need 2 gig of RAM and 2 cores. If you don't have that, then get out of my room. You need some drives to replicate. Like I said before, fixed disk is all I really care about, right? So if it's SSD or NVMe or SAS or SATA or iSCSI Target or VHD, I don't care. As long as it's not like a floppy drive, we're good. And you laugh. I heard laughs. One guy asked me about replicating between writable DVDs. Synchronously. Like we're not talking milliseconds now, we're talking seconds in latency. Okay. I need some kind of network, obviously, to replicate on. We're very agnostic here as well. Ethernet, TCP, RDMA, we're fine. There's no need for fiber channel. You can certainly use fiber networks, like dark fiber is great for replicating across metropolitan areas, and it's fairly available in those scenarios. And firewall ports, obviously. But hey, it's the cool part. SMB3, right? No new weird ports. Ports probably already open. Hopefully, all set. So we're using industry standard storage, networking. The folks from like Dell and stuff don't like to say commodity. We try to say industry standard. Commodity sort of sounds like, you make cheap trash. No, industry standard. So networking, nothing special. Storage, nothing special. Servers, nothing special. You're not buying. Anybody here buy expensive SANs? Oh, you can admit it. You all have SANs. Anybody buy expensive replication from the SAN, a la carte, extra? Doesn't ever come with it. Is it really, is it cheap? Is it very, very inexpensive? Or is that where all the margin is? Yeah. So mine costs whatever server costs. We'll see if anybody can beat that. If anything, you can use me as a negotiating tactic on your next deal. Okay, The synchronous workflow is really easy to understand. I have an application writing against a source server and a destination server, and my clicker has just gone to sleep. There we go. So I make an I.O. It actually writes to a log on the source. It writes to a log on the destination. This is the synchronous workflow. And once it's acknowledged back from both spots, it returns to the application. Very simple. And then that data is itself destaged into what the app was really trying to write to, which was, the data drive, the volume they actually were headed for, the D drive, this mount point, whatever. All these HDDs out there. So here's the limits of my PowerShell or PowerPoint animation abilities. I worked on that very, very hard. And then for the follow-up, okay. That's basically it. It's very simple. It's simple because it's the only way that really works particularly well. And people have been using this type of methodology for 20 years, and it works fine. We're just late to the party. But not just did we show up late to this party and only have replication. We said, well, people have been at this for a while. We need to make sure we meet, a fundamental bar of the competitors. So we allow thin provisioning. I will show you a very fun, very fast demo on thin provisioning tomorrow. Network constraint. Hey, I want to replicate, but I want to use this network, not that network, that network. Yes, out of the box. The range on this is very slow. RDMA, Chelsea, Rocky V2, InfiniBand RDMA with, say, like Metro X extenders, all supported. And we actually test and use all of them in our labs for real, with real fiber and real cables and nothing synthetic and nothing fake. You can replicate inside of guests or hosts. And I can replicate whatever you like. You want to replicate files? Fine. SQL? Fine. VMs? Fine. Weird application stuff? Fine. Block level replication? I don't know and I don't care what you're up to. We support write ordering to make sure that the SQL folks are happy. They demand that we support write ordering assistance to groups, so we do, to guarantee that all I.O. can happen in exactly the order they said it should happen in. We support delegation so that when you say, I work with Phil and Klaus, and I trust Phil and I don't trust Klaus, I can just allow them, without being an administrator, but simply being a replication administrator, manage this system. So let's do a quick demo. And I have a graphic designer who works for me. So my demos are very pretty. Here's Seattle and Bellevue. That's like Washington in the middle. And I have some kind of, under lake cabling going on here through dark fiber. Actually, it's kind of floating on the top of the lake. I have a stretch cluster running with virtual machines. I can have VMs running in Seattle. I can have VMs running down in Bellevue. They can be replicating in different directions, so I don't just have this wasted DR site that drives the accountants crazy. And I really am doing this. Here's a real set of servers. These are Dell R620s, I think. One of them's turned off right now in my stretch cluster. It's off for maintenance. And I'm running how many nano VMs here? Let's count. 500 nano VMs on a 128 gig of RAM system. I still have 30 gig of RAM left because nano VMs are amazing. And they're actually running, here's the proof, because I'm going to show you all the advanced console logon features of Nano Server. Here we go. That's it. That's all you can do. Done with Nano. These are like ASP, like IIS web servers running. And then I also have a SQL server running. You'll see in a little bit here. But here's the storage. Here I'm an old-fashioned guy. I'm actually using the old JBOD stuff. These are MD, what are they, 30 to 60? Thanks, Phil. And I'm continuously replicating. You see the synchronous, the continuously. Notice how little disk space I'm actually using for those 500 VMs. That's just kind of a little bit of trivia there. So your storage salesman's not going to be real pleased with this Nano situation. So then I have my terrible query. And what's terrible about it is it creates a million NEDs. Your worst nightmare. 1 million NEDs, and I'm pumping all this data and running these VMs live, and it's all happening in Bellevue. And then comes the most likely scenario. Giant gorilla attack. There goes Seattle. There goes my servers. But who cares? All of it was synchronously replicated back into Bellevue. Every single I.O. I ever made. Here's what actually probably happened is I work with Phil Moss. I told him to turn on server 1. He took that to be, let's turn off server 2, and cut the power because Phil Moss is an idiot donkey. So now I only have one node left, right? This is the real disasters aren't floods and fires, they're people, right? So all of my replication failed over automatically. I didn't do anything. This all happened at 3 in the morning. I'm asleep. I don't care. All my VMs started back up automatically. My start priority, my dependencies I talked about earlier, they all started the right way. In theory, no one noticed. I needed the time to get the VMs running again, but every single byte of data was safe and protected the whole time. So the worst case is I had a temporary outage of communication, not of data. I look at my SQL database. It works. I could log in. That's a pretty good sign. I could go and look at all my rows, start scrolling through that and see the bliss that is endless NEDs. My VMs are still working. All of my nano VMs have started back up. My ASP core IIS server VMs have gone running. They're talking to my SQL database. Everything's happy. And as far as I can tell, I better be really good at watching through monitoring and event logs that there was a problem. I might miss it. Once I get the power back on and fire Phil, the nodes join back automatically, the cluster's back to normal, and you have a stretch cluster which occupies 2 physical locations, but acts just like they were all in the same rack. That's pretty cool. Our friend Daniel Weissenborn at ClearPoint said, this was it. This was the last piece I needed to get rid of my SAN. That was the only thing he didn't have. I needed to get replication software. Now I can do it. Now I can stop using my SANs. If you want to see more about this, or read more about this, or hear more about this, it's all there tomorrow at 4. If you want to give us feedback, SR feed goes right to me and my dev team. It does not pass through marketing, sales, managers, or anything. You can say what you want. And we will listen, and we will respond. I don't know if we will do what you say, but that loop will be complete. And if you want to listen to announcements, obligatory Twitter advertisement. Oh, it's wrong. I spelled my own name wrong. Here, let's do this. Here, let's go and let's fix it. There we go. You're going to like that. Because it's actually NerdPile. Here, if I can do this. Control, Shift, let's just do from slide. What's that? Autocorrect. Yeah, there's no NedPile in the dictionary, trust me. And in fact, the shocker is there was already a NedPile on Twitter. Who is this guy? I've never heard of him. I'm the only NedPile I've ever known in my entire life on the earth. Okay. We've been working on all this stuff for a long time. So at the beginning of this, I said, I promise you we're not going to talk about all of 2012 and bore you to tears about all the long roadmap. But if you didn't know about that, these are the places to go. If you remember these links or take a picture, whatever you want to do, obviously these slides are all made available to you immediately. These spots cover everything we've covered and all the stuff we've covered before that and before that and before that, going back 5 years. This has been a big evolutionary process. We've reached now, basically, I think, the sort of pinnacle of what we started out doing in 2012. All this stuff has been covered and will be covered more. Here's one of those giant slides you shouldn't read, you just take a picture of. And I'll leave it up here for 5 seconds for pictures, and then we'll have a few minutes left for questions. Anybody else needs to take a picture? Good. Zoom in it. Okay, so what questions do we have left to address for you? Yes, sir? Yes. Technically, I don't know what your file system is. When we test, this is some trivia, the question was, do I care what file system you're replicating? The answer is no. When we test, we often test without a file system. But obviously, Windows wants you to have a file system like REFS or NTFS. Yes.
No, VPN doesn't use a file system.
Okay.
Can we replicate VPN with stored replication?
Yeah, I mean, we typically test with raw disks. So if you want to put ext4 on there or go find yourself a copy of FAT16, knock yourself out.
Back there?
Yes.
Questions. Read-only replica? Is the replica a read-only copy? Second question, multiple replica destinations.
Okay. Those are two things I cover tomorrow, but the question is, can I do a read-only copy of replication, and can I do a transitive or multiple copies of a destination? Not in this first release. It's a read-write to a dismounted secondary. But those are our top two requests, and don't tell anybody on this recording, but we already did it, and we just haven't shipped it. So there you go. Yes, sir?
Can you summarize which features require Hyper-V?
Features require,
Which features require Hyper-V and all of this stuff?
Do any of them?
None.
No.
None of them. They just happen to love Hyper-V.
So you can actually run most of these features, well, you can run all of these features on the bare metal host, and a lot of them you can run inside virtual machines
Yeah.
as well.
He doesn't talk about it, but he actually runs guest
can-
clusters inside Azure sometimes using S2D.
There is actually a blog post out on that, on
Yes.
the link, how to do it. With Technical Preview 5, I will update it with the GA because it's going to be simpler. Yes.
Actually, Klaus thought you might want to expand on that because, of course, S2D is the idea to give you a way of doing highly available storage in Azure.
Well, it's a way to create a highly available, scale-up file server in Azure if you need a file service. Basically, well, so let me expand on it. There's a couple of customers that have come to us and asked us, hey, wait a minute, I need to put this workload inside of Azure, but I need a cluster. It's relatively tricky to create shared storage on top of Azure because it doesn't provide shared storage semantics. So what they do is they then create a cluster using Storage Spaces Direct because it's a shared nothing architecture, and then you can basically run your application on top of that. Oh,
Is it a Hyper-V replica killer? No, they're really complementary, and I get paid the same if you use either way, so I really don't care. But if you need synchronous, if you need 0 RPO, then SR is for you. If you need something which, is into the stretch cluster scenario, for example, no. But if you need something which is application specific, and you like the ideas of multiple kinds of checkpoints and being able to run like a test VM and see what's going on over there, Hyper-V Replica. I mean, I'm at a fairly generic storage system, and my answer is use both. Replicate synchronously off to some DR site, and use Hyper-V Replica to replicate off to yet another spot, and use them both.
So there's one key scenario where Hyper-V Replica works very nicely. SR, remember, you've got to do the whole volume. Hyper-V Replica, you can just do
It's
the
file-
VM.
it's file replication.
If you need an application story for HA, Hyper-V Replica.
Yeah.
If you want block level storage at the volume level, SR.
I will say also at scale. I mean, Hyper-V Replica does not tend to want to replicate hundreds or thousands. Like that nano scenario right there might make Hyper-V Replica upset, but I won't be. Estimate from over this side.
Yep.
Is there a reason you're not talking about unification?
Because we're keeping secrets from you.
Friends don't keep secrets.
yeah.
This is Microsoft, baby. We're not friends.
Do you want to take it or do
Yeah, I'll answer this.
The answer is dedupe in REFS? The answer is no.
But you can use NTFS.
Is the answer, can I use NTFS on that system for archival stuff? The answer is yes. And is dedupe coming to REFS? The answer is they think about nothing else on that team right now. Way in the back there, sir. You've been holding up your hand a long time. There is not.
Storage live migration.
Well,
Create a new volume, migrate your VMs over, and abandon the old
Yeah.
volume when empty.
or REFS. RFS is your friend.
Well, he's saying he wants to migrate from
No, I know.
NTFS to RFS, yeah. Or just robocopy.
Yeah.
Yes.
Also your friend, sort of the friend that kicks you in the teeth every once in a while. Yes, sir. Distance or latency question on storage replica is a great question. It's a complicated answer. The short answer is I don't care. The longer answer is you should care about latency, and I recommend 5 milliseconds or fewer for round trip on synchronous. On asynchronous, I go back to saying I don't care.
Your latency ultimately is going to be your bottleneck. So the more latency you have, the slower your overall storage curve is
Yeah.
going to be.
And some people just don't care about latency. Right. I mean, if you get into, we talk about latency in terms of microseconds and occasionally milliseconds. We start getting a little edgy on milliseconds. You talk to somebody from SQL and 20, 30 milliseconds is like, well, that's just kind of normal. So it depends on you, honestly. Other questions? We still have 1 minute left.
Gentlemen
Chance.
in the middle.
Oh,
Or ma'am, yes. You.
yeah.
The performance hit on storage replica, that is also complicated, which I will definitely want to show you in the tomorrow's evening or tomorrow afternoon session. But depending on how you do stuff, I will demonstrate a way for you're replicating at 40 or 50 kilometers, and it's faster than not replicating, depending on your storage arrangement. So there is a hit. We can't pass through an entire mechanism of stuff, all this extra juice of logs in order to get faster in general. But we do some things with I/O aggregation and sequential I/O and journaling on your SSDs and stuff that can make things actually faster than not using us at all. Yeah, we have time for one more. Yes, ma'am? If I lose connectivity between sites for replication, nothing happens. I just let my IOs continue, and I start queuing them up in that log. And if the connectivity comes back, I will play out the difference of that log, which is very fast. If it doesn't come back for a long time and the log wraps, I will actually use something called the bitmap to replay all the blocks that changed. And if that takes too long or is broken, then you should really call me. Because that's not supposed to happen if that doesn't work.
Is that in synchronous as well?
In either case, synchronous or asynchronous, yes, we will repair the whole thing under the covers. In fact, you'll just have to monitor to find out that it happened. Because we're not going to stop and tell you, except in the eventing. Yes?
If you've got under 5 milliseconds between data centers, why do you stretch SSD?
Well,
5 milliseconds is a long time. You saw this other system, we're doing 250, 270 microseconds. But
nothing is stopping you,
if you,
honestly.
if you have a campus-style setup where you have, let's say, 10 gig RDMA enabled and you got super low latency between two buildings, you could set up store spaces direct.
Yes.
But in general, store spaces are not intended. It's not a DR solution. You're effectively just splitting it. And you can use, and we'll talk about that later today, we have higher level of fault domains. You can define like chassis and racks to make sure that the alternate copies goes in different racks, which you could then place in physical different buildings. But now you're sort of bleeding into the gray zone between these things. Yeah. But in fundamentally, Store Spaces Direct is not about DR. It's an aggregation of stores, creating pools and creating virtual disks. That's its mission. For DR, that's Storage to Replica.
No. So I think this is a really key point. Storage Spaces Direct is a scalable data delivery platform. It is not a distributed DR or failover scenario. Make sense? Because if you think about it, if you actually scaled it across multiple buildings, the machines coming in to talk to it would also be hitting all of its nodes. Yes? So it's about S2D is a distributed and scalable storage platform. SR is part of the DR story, and you can happily build 2 Storage Spaces Direct clusters with your DR solution. Make sense?
Not between clusters. That's sort of intentional right now. We are going to make the scenario you're talking about. We are going to eventually make it work. There's really some pieces holding us back on it right now. Not in setting it up. We set it up and it worked, and we were very pleased. And then we started finding some operational aspects that were not as fully baked. So technically, it already works fine. The same thing goes for scale-out file server. Some people usually ask about scale-out. If your latency is very low, replicating it is fine as long as you want to pay the penalties of clients who might end up going to weird locations.
We'll be in the front for more questions.
Is there a limitation to that backlog?
Thank you.
Thank you.